Quantum physics. It's the key to understanding our complex world. This is Robert Manni, host of Guys TV, and this week my special guest is Dr. Charles Liu. We're going to talk all about quantum physics, and it all starts right here, right now on Guys TV. You can also catch me on KCAA Radio here in Southern California, Guys Radio, my worldwide podcast, and we're on UK Health Radio all weekend long. Guys TV, Guys Radio. Thanks for your support. Okay, Guys Radio, it is the interview portion of our show, and as promised today, we're going to talk about everything quantum. My special guest is Dr. Charles Liu. He's got a book called The Handy Quantum Physics Answer Book. For those who are watching the show, I'm holding the book up now. It's a big, thick book, but it's very nicely laid out, and it's got a lot of questions and a lot of answers, and it is terrific. If you ever had questions about things that are quantum, anything from, what's the difference between quantum reality and the 3D reality, or what's the unified field, or how does AI work, or everything's covered here, and it's really helpful. And we don't have enough time to get into the whole thing. So let me tell you a little bit about Dr. Liu, and we'll get started. He's a PhD, professor of astrophysics at the City University of New York's College of Staten Island, an associate with the Hayden Planetarium, which is wonderful, and the Department of Astrophysics at the American Museum of Natural History in New York. And he's host of his own podcast. Everybody's got a podcast, the Liu Universe. I love that, with Dr. Charles Liu. His research focuses on colliding galaxies, starburst galaxies, quasars, star formation, histories of the universe, and he's been published all over the place. And he's even done some work with Neil deGrasse Tyson, who we all know. And he's just an amazing guy. And I love the fact that the book is put together that's very accessible to anyone. So welcome to Guys Radio, Dr. Charles Liu.
Thank you so much for having me. It's a real pleasure to be here.
Well, let's start at the beginning, because for our listeners, everybody's heard the term quantum and quantum physics, and a lot of things are happening, and it seems like things are happening faster than ever. But just to level set, could you explain what exactly, in your opinion, and from the science behind it, what is quantum physics?
Sure. Quantum physics is essentially talking about how fields and particles interact with one another at the smallest size scales in the universe. We're talking about volumes and lengths that are smaller than, say, 1/1,000,000th of an inch. At that level, the normal laws of physics that we think about, like motion, force, momentum, things like that, they break down. They follow different mathematical properties. They wind up creating really interesting, not weird, but kind of fascinating and just different ways of interacting between particles and waves and fields and energy and things like that, which then translate outward into our regular lives in ways that are quite surprising, but also quite ordinary.
That's amazing. So at that level, when you get that granular, things don't behave with the same rules that we have in our traditional kind of 3D lives.
That's right.
Same thing with time. So to me, and correct me if I'm wrong as a layman, when I hear quantum, it's like all bets are off. It's like what could possibly be, versus our 3D reality, which is much more this and then that and then that, very linear aspects of time, etc. Am I on the right track there, doctor?
You're on the right track, with one important caveat. Okay. It's not that all bets are off. It's that the bets that are normally on in our macroscopic world are not the same bets that are on in the microscopic world. In other words, think of our existences as human beings as having trillions upon trillions of cells, right? And each cell has trillions upon trillions of little atoms and molecules and things like that. On each individual particle's level, there are specific rules that it has to follow. But those rules are not the same rules that we as an aggregate of those particles follow. So if I'm, for example, in orbit, I'm wearing a spacesuit or something, in orbit around the Earth, I follow certain rules of motion that Isaac Newton figured out hundreds of years ago and things like that, and that Albert Einstein have worked on in the past century or so. But it is not the same set of rules that an electron does follow when an electron is orbiting around the nucleus of an atom, you see. So they're both orbits, but they don't have the same rules. If an electron orbited an atomic nucleus the same way that a space ship would orbit the Earth, then it would collapse. It couldn't survive for any period of time before it turned into just a mush of subatomic particles and energy. Instead, these other rules are now based on quantized energies, based on wave particle duality, based on quantum uncertainty. These rules, they're very strange to us, but on that level, they make perfect sense. And so when you add them up together in their billions and trillions of individual interactions, they actually wind up manifesting in ways that are very familiar to us.
So it sounds like there's universes upon universes upon universes as you drill down to the smallest particles, and how they kind of work together, but then they can be influenced.
That's a good way to put it. Um, in our one universe, there are lots and lots of substructures, shall we say,
Okay.
organizations, right? A solar system is one system, for example, that's got a star in it, our sun, and then a bunch of planets and asteroids and things like that, right? An atom is also a system, and it contains whatever particles it has, and electrons, protons, neutrons, things like that. And each of those systems could be thought of as its own kind of cool, independent thing. But then they interact outward with other systems, atoms with other atoms, people with other people, stars with other stars. And that's sort of how you get the aggregation of our experiences in our regular lives. So on the quantum level, that atom is going to interact with some other atom very differently from the way that you and I are interacting right now, but it's still an interaction that eventually leads to stuff that we can observe and that we can experience.
Got it. There's a term I was reading about, the unified theory, and I guess the question is, what is the difference between quantum and classical physics and the physical laws?
Great
Why
question.
are they different, and how is quantum different than everyday life?
Wow. Um, there are many ways. I'll try to stick with ones that are most easily we can see most easily being relevant in our daily lives.
Okay.
Okay. The three concepts that I talk about in the book, which, as you rightly said, is not for specialists so much as it is for us ordinary folk. And it's not just a reference book, but it's a storybook about how we learned about all these different ways of doing things and learning about it. And the first thing that we figured out long ago is that when we're trying to figure out how hot objects radiate their heat, okay, uh, when people tried to measure them using the non-quantum laws of thermodynamics in the 1800s, they couldn't figure out why the mathematics was coming out the way it was. So then what happened was right around 1900, a German scientist named Max Planck basically said, you know what? I'm going to go to an idea that Isaac Newton proposed centuries ago and just make a mathematical hypothesis that every piece of light is not just a wave of energy coming out from this hot object, but also a particle of energy that's been carrying out this piece of energy, that's heat in this case. And when he did that mathematical technique, he found that the math fell into place. So in other words, under that particular circumstance, he figured out that you could think of light as either a series of particles, which we call photons today, or a whole bunch of waves that are sending energy out through space or through the air or wherever. And so this wave particle duality was the first thing that really set us off and made us understand the difference between quantum and classical physics. We figured out later, a guy named Louis de Broglie, a Frenchman, figured out that actually even large particles, such as humans or rocks or planets, are also waves. You and I are waves, or packets of waves, just as surely as we are also pieces of matter. The difference is that we are big enough that our wavelengths are microscopic. We can't measure how small our waves are using ordinary means in our lives because we are so large as objects. But atoms and molecules and subatomic particles, they are small. As a result, their waves are about as big as they are. So they exist really well as both waves and particles. We think of ourselves pretty much as just particles because our waves are so small compared to our size as particles. But their waves, these subatomic particles, are about the same size as their particle size. So their duality becomes mixed, which is super cool, right? Think about us made up of trillions and trillions, or even more than trillions of little particles, but also as little waves. And all those waves are interacting in such a way that when they manifest out, the total sum of their interactions out with the rest of the universe in which we reside manifests as us as particles. That,
Let's pursue that a little bit because
sure.
so we have we have trillions of our bodies are made up of trillions of microbes. So there's
Yes.
individual microbes then. So it's a group. And so it's all dense within us because we're 3D kind of beings. But
Yes.
that means that I want to get to kind of consciousness that we
Okay.
can actually, what I say every morning is I love all I love you microbes. I love
Yes.
you. And I always get a rush when I do that
Yeah.
because I feel from what I've read about microbes, there's this whole universe inside of me that's working, here's me, but inside is me also. And it's made up of all these little microbes. Talk to us
Right.
about that and what people can do because I like to get practical on the show. I'm a guy's guy. I'm not an astrophysicist like yourself, and I want to bring information that people can work with. So talk to us
Yeah.
about quantum physics and consciousness and how people can kind of work with that to have a better life.
Sure, sure. Yeah, you described it so right. Although we think of ourselves as individuals, we are also aggregations, right? We have those microbes living inside us. We're also made up of cells that are part of us and not distinctly microorganisms on their own. All of them together are interacting on a microscopic level. And there are ways that we still don't understand very well at all how they're doing that, right? Many of our medical colleagues are trying to realize, wow, those trillions of microbes inside are actually creating some sort of macro response, right? But that doesn't necessarily have to get to the quantum level. We, for example, our hormones, our enzymes, our thoughts, they move on a macroscopic level, right? They move several feet or several inches in our bodies, and they happen very, very quickly. And you can just have a small amount of, say, adrenaline go through your body, and your whole body within seconds, or even a fraction of a second sometimes, reacts, right? So these are the aggregate of all these little tiny quantum effects that have turned into a macroscopic effect, a non-quantum effect that happens with us. Now, as far as consciousness goes, that's one of those things we don't know how all those little tiny particles or those little tiny interactions create something that we recognize as this macroscopic consciousness. Possibly it has to do with the quantum effects that are going on inside our brain. We are trying to figure that out. I'll use an example in our regular lives. Nowadays, ChatGPT, right, and AI have made the news quite a bit. The idea is that, well, you can ask one computer a question and it will query out to all the computers in the internet that have all this different information, gather as much as possible, synthesize following certain rules of grammar or punctuation or language, and then spit out an answer that's a synthesis of all of that, right? That's a kind of artificial intelligence. Turns out that the human brain has many times more neurons in it than the internet has computers. We have many, many times more connections between those neurons, those synapses and so forth, than there are internet connections between devices. So everything happening in our brain, which most of which is on the quantum level, little bits of matter, little bits of information, little bits of energy sliding back and forth, is somehow combining on a system that's even more complicated than the best AIs we're using on the computers now to do stuff in our head. That may well be the origin of consciousness on the biological level as we understand it, but we don't have enough scientific knowledge or expertise yet to really dope all that out.
It seems to me going forward, we have to preserve the human as the human is now. And there's a lot of talk about, chips and stuff like that and
Mm.
AI and maybe a bifurcation in terms of like, I'll say regular people and people who have AI or some type of intelligence embedded in them.
Mhm.
What is your take on that? And what is the benefits of this bifurcation and what are the dangers?
That's a great question. Well, quite frankly, we're all still trying to figure out the exact implications of all this, right? It's very, very true that we are so much more complicated, each one of us, than the entire internet put together, that what's happening in our heads can't be duplicated on many levels on the internet. On the other hand, remember that the internet and AI is something that we humans, with our natural intelligence, have created, right? We're trying to have these machines help us
Right.
understand what we don't understand about us. So, in that sense, it doesn't have to be scary. I would think I would put it this way. Astronomers, we have been using AI and machine learning for decades. All right. Back before it could beat humans at chess and stuff like that, we were already trying to get computers and set up algorithms and so forth to say, hey, I've got information on 100,000 stars that I can't process quickly, but can you sort things out in certain ways or set them up in certain ways so that I can understand big ideas and then understand and interpret them once you've done all that legwork, right? This is the kind of thing that AI can do for us right now. If we want to augment ourselves, right, we wouldn't augment ourselves with things that we can do quickly and easily, right? Or things that we can do better than the computers. What can a computer do? What can a calculator do? It can do the same thing over and over again very quickly and very accurately, right? So I can tell a computer to add up numbers and it'll do great. If I start adding hundreds or thousands of numbers at a time, sooner or later I'm going to get stuck because my brain is designed for looking at the world and reacting to it or interpreting it or deciding what to do once I get a certain input. My output would be different. So we want to use those skills to our benefit. And I think there there only comes a danger when we use it in ways that we don't understand or that we use tools that are unwise. A fire, for example, uh, in our fireplace can keep us warm, but a fire for the rest of our house means that our house burns down. AI is that kind of tool, in my opinion. We use it wisely, and it can only be to our benefit.
Awesome. The Handy Quantum Physics Answer Book, my special guest, Dr. Charles Liu. Wow, we can talk about so much. I'm thinking about going forward in terms of how AI is going to impact the workforce. And to me,
Mhm.
it's just like when the internet came on. First, it was
Yeah.
like, nobody's going to make any money. This is just all good for people. And then somebody made $1. And then now it's all about the money in a lot of ways. And then there's the social media, which is a whole different ball game. But
Yeah.
to me, a lot of the research, like let's take the legal business. So all these associates that spend all their time digging through these big books in the libraries, you're not going to need that. Chat
Right.
GBT or whatever, bang, get the information. But what
Yes.
the AI can't replicate, they could give you the arguments as a trial lawyer, the logic and the
Yes.
proof, but
Yes.
they can't give you the charisma in terms of knowing how to stand in front of a jury and
Yes.
connect with them on an emotional level. And that's
Yes.
what it's really about selling because not about information, because I'm in the advertising business. It's all about making an emotional connection between the consumers buy based on emotion. You can give them all
Mhm.
the facts in the world. It's emotion. It's the same thing with how we interact with each other. So
Mhm.
the way I see it is there's going to be a need for human creativity that
Yes.
the AI is never going to catch up to because it's always because humans are they're predictable, but there's always this little X factor there with humans where you never know and something always comes up. Music can be mathematic, but there's always a new song that doesn't necessarily fit that template. But things
Yes.
that are templatable, if you will, AI will be able to do all of those things. Does that
You
make
hit it.
sense?
You are absolutely making sense. You've hit the nail right on the head, in my opinion. I tell all of my college students, in fact, that they have to get from their college education not just a set of skills that they can replicate and do over and over again, but they have to make themselves better than an AI algorithm, than some sort of search engine. They've got to do better. And the good news is If we know how, we can, right? What you talked about in terms of finding legal briefs or getting information like that is definitely there. Uh, Heck, at this point, you can do telemarketing with a filter in front of you where the AI filter will just actually change your accent for you, or
Mhm.
maybe even translate to a foreign language in real time. So they're not going to need the skill of being able to read a script in a certain way. They're going to need the skill, like you said, of connecting to the customer, right? It's a whole different set of skills that at this moment, the AI algorithms and tools can do some of, but there's a lot that they still can't do. And preserving that, in my opinion, isn't just about technology or learning from a book or something. It's about what you and I are doing right now,
Mhm.
talking to one another, asking questions, seeking answers, right? The book, the Handy Quantum Physics Answer Book, um, it's part of a series of handy answer books. But what they really are their handy question books, right? What question do you have and how do we try to answer it? The simple answer is you can look it up, right? And that's something that AI can do. The more important answer is once you have that answer, what's the next question to ask? Now what? What do you do next? And that part, we still have a big advantage on AI.
Do you think, Dr. Liu, as we're having this conversation, and thank you for bearing with me, I'm just asking the
Of
things I
course.
would ask you if I was sitting next to you on a cross-country flight.
That's how
Um,
it ought to be. I'm really glad we're having that conversation. That's great.
so if somebody's chipped, let's say they're on that path, they get
Yeah.
chipped and they want to do that to have and I've heard people say, I want to get chipped to have that professional advantage.
Hmm.
So does that then take away that need for the emotional connection? Because if the AI can give them what they need via chip, which is takes out the emotional aspect of that, is
Oh,
that
wow.
something, does that separate where the emotional cell, if you will, only works for unchipped people, but the chip people will respond to the AI?
Wow, that's a terrific question. The technology is still in its infancy, right? We now know. I had a neuroscientist guest on my podcast about a year ago, Dr. Nikki Driscoll. She and her group are in fact talking about ways not so much to chip people, but to hook them up in a way so that they can use their brains' tiny electrical signals without moving their bodies or anything like that to get a machine to do something, or maybe to get an arm to lift when they're themselves have like a severed nerve or something like that. I mean, it's tremendously interesting things. But what those chips or that technology can do is just amplify what's already going on in our own heads. It itself doesn't have its own sort of impetus to do something, right? The algorithm isn't interested in lifting your arm just because it wants to lift your arm with this Neuralink connection, right? Indeed, instead, what it is that I want to lift the arm. I need help, and so I use that chip, right? Think about that in terms of that emotional connection. If you are a person, for example, that has no emotional connection with another person, but you want that person to do something, right? How do you make that happen? How do you make that interaction occur? Usually it's through some sort of convincing, right? If it were some less healthy interaction, it might be a coercion of some kind. But either way, you're still appealing to some sort of reason or emotion or logic that the other person has to receive. And so I think the chip can help, but it's never going to replace what we can develop. Remember, each human brain has more nodes and more connections than the entire internet has today.
Mhm.
So we are still in charge if we want to be, right? If we don't want to be, and we just want to let the machines to do things for us, they're now at the point where they can do something for us. Like we can tell a machine assistant, like, order my lunch for me, right? And it will order a lunch for me, but it may not order the lunch that I want to eat. It may not order the nutritious lunch that I need. It may not give me joy, right, to have lunch with you. Uh, and that's kind of where we are at the moment in that. So I think we're okay as long as we're wise about how we use our tools.
Mhm. Uh, to me, we're at a dangerous precipice because the way our culture behaves now is it's pushing separation, whether
Mhm.
it's social media or, we don't interact with our neighbors in the same way that we did 30, 40 years ago. And so when the media tells you, like that the debate or something, this is what happened. They tell you what you're supposed to think. And people are going along with all of this stuff. So there's a push, I think, to getting people to become more amenable to order lunch for me.
Yeah.
And, instead of
Yeah.
I want something nutritious and I want this and I want that, uh, just the lazy way of doing that, because it's our Western culture is now, it's just the money. It's been reduced to that in many ways. And
Yeah.
so I'm wondering, if AI is going to take us faster and further down a dangerous path, and what we need to do to kind of rein it in and protect people who want to be organic human beings, if you will.
Mm. Great question. AI is indeed a very fast-moving frontier of human interaction and human tools, but it's not the first revolution amongst human interaction, shall we say. The monetary impulse has always been there, right? And the creative impulse has always been there. Um, if I remember correctly, about a century ago, the printed word was castigated by many people because it was being ruthlessly commercialized. People used to think that the printed word using a Gutenberg press or something should only be for art books or for philosophy or for learning and so forth. But then here came newspapers and magazines, and they had cheap headlines and tawdry stuff or even untrue things, what we might call, fake news today or something like that, right? Just so they could sell copies, right? We had the yellow press with newspapers. We have these advertising things. Suddenly, posters came out. You could mass produce color posters with, I don't know, Santa Claus on holding a Coca-Cola,
Yeah.
things like that.
Mm-hmm.
And so there was a revolution then too.
Mm-hmm.
And what did people have to do eventually? Most of us today figured out, either through education or through personal experience or learning from others, how to use that information in a benign fashion that wouldn't destroy us, but instead would actually help us instead. We would allow ourselves to use this technology carefully. And even though there were big commercial interests, like you said, or political interests, that would try to exploit the persons using this new technology, this spreading of information in sort of unregulated ways. We came out okay because there were enough of us who sort of saw the value of being who we were and maintaining that, regardless of what new skills or what talent we had, right? Literacy, the fact that the majority of Americans can read and write, has turned out to be a good thing as opposed to a bad thing.
Mm-hmm.
I am hoping, although I don't have enough evidence yet, that AI and the quantum technologies that have made that possible are another step in that improvement of humans. There is going to be damage along the way. And there are many of us that are unfortunately going to feel the negative effects of it, whether we want to or not. But if we know it and we understand it and we see it in operation or happening in our world, then we should be able to counteract it and understand, well, you know what? Sure, these things are going to tell me these things, but I'm going to go read myself. I'm going to go find more stuff. Yes, this is isolating me from my neighbors, but I'm going to actually go and walk over to the park and say hello to people. Uh, these kinds of things, hopefully, over time, are ways that we humans can prevent that kind of negative result from coming from technologies like AI and other quantum things.
Fantastic. My special guest, Dr. Charles Liu, again, the book, The Handy Quantum Physics Answer Book. Let's get to some other areas that are kind of interesting. When we talk about quantum, it's like two things can happen at once, the same time. A cat
Yeah.
dies, it's not dead. I recently did an interview with Cynthia Sue Larson about the Mandela effect, and I got a lot of reactions from people saying that's nonsense, where the Mandela effect started with, oh, didn't people thought Nelson Mandela died in prison, and then all of a sudden he's president of South Africa, and then Larry Hagman, the star of Dallas, I thought he was dead, and then
Mhm.
he's not dead, and things like that happening
Yes.
with corporate logos and a lot of stuff like that. That can take it all the way to like teleportation. How we can, like in Star Trek, you break down the particles and you're somewhere else. How does all that stuff work? What umbrella would you put that under, Doctor? And talk to
That's
us about it.
I would look at those kinds of things in from two different directions. Okay, direction number one comes from the complexity of our human brains. And then direction number two comes from the complexity on the quantum level of our universe. Okay, let's start with that one first, because it's sort of more directly to the physics side of things. You know that we explain the universe using math a lot, right? But what happens is, and this doesn't always manifest itself clearly in regular conversation, a mathematical equation or a system that explains the way the universe is can at the same time explain other things that aren't part of our universe. That makes sense. In other words, equations sometimes have two answers, right? Sometimes they have three answers or something like that, or even more. So one of those answers reflects our reality. But are those other answers any less valid than the one that reflects our reality, right? And if you take the philosophical opinion, and physics does have philosophy in it as a component, right? If you take the philosophical opinion that those answers may well be real too, just we don't experience them, then you can get to what is called the many worlds interpretation of quantum mechanics, where you imagine that every time there's a quantum event that happens, its counterpart event also happens, but just not in the universe that you and I share. Okay. So the famous experiment that was never conducted, but it's just a thought experiment called Schrodinger's cat,
Mhm.
right? After Erwin Schrödinger, who sort of published it first in Conversations with Albert Einstein. He basically said, imagine a cat that's in a box. We can't see it, but it's in with a particular quantum device, a nuclear process. If the radioactive decay happens, then the cat dies. And if the radioactive decay does not happen, then the cat doesn't die. We can't predict, we don't know exactly when that quantum process will happen. So until we open the box, we could think of the cat as being alive and dead at the same time, right? So now imagine that imagination, right? That quantum cat. But instead, we don't open the box at all until we know that the quantum event has occurred, okay? Once that quantum event occurs in our universe, in our time stream, basically, we know that the cat has died in our universe. But in all the other mathematically solvable answers of this equation, that cat has not died yet, right? So during that time, before we opened up the box, knowing that the cat had expired, the remaining solutions, the remaining possibilities have all happened. And they're happening now. And each one has spawned an additional reality or an additional time stream. So there could be a huge number, maybe not infinite, but certainly so many that we couldn't count them in a lifetime, of realities that are happening now, only one of which is ours, but the rest of them might actually still be true. And so that's what's called the many worlds interpretation of quantum physics. So that is sort of how something can be both alive and dead at the same time, not in our same universe, not in our same time stream, but somewhere else that we can't access, that we can't touch.
What is a then the multiverse then?
Great.
Is there different levels of frequency that does that have anything to do with this?
It kind of does. You could think of each reality that comes about from this bifurcation of quantum events as its own universe, right? And so there is a multiverse in the sense that there are many different universes. There's one universe where the cat dies, and there's another universe where the cat doesn't die. And there's a universe where the cat dies tomorrow. And then there's a universe where the cat doesn't die tomorrow. And there's a universe where the cat jumps out and jumps away. And then there's a universe where the cat sits there and sleeps and stays awake. So all of these different ones can continue to coexist, but there's no way to interact between them. So that, in a sense, is a multiverse. There's another kind of multiverse, which also we can't prove yet, We don't have the experimentation or the capabilities to show whether this is true or whether we can falsify it. But the idea that the universe early on in our Big Bang cosmology, as we call it, had something called an inflationary period, not price inflation of like goods and services, but the inflation of all of space and time just kind of went whoof in a huge balloon-like expansion. If that happens many, many times, then each of those balloon-like expansions contains a universe which can't interact with any of the other balloons universes. Those together, collectively, could represent also a multiverse.
What can people do on a practical basis to use the quantum aspects of how life is on our planet? For instance, can they, we have a lot of markers. I'm very interested in the aging process, and
Hmm.
we have a
Hmm.
lot of markers that our culture gives us. Like, I have so many friends who just turned 70, and
Yeah.
all of them, I hear this 70, and they branded themselves as it's a mortalization of yourself, as like,
Yeah.
this is the beginning of whatever. And
Yeah.
I don't think it's a healthy practice. So I'm wondering, can we, with our perspective, can we
Yeah.
keep ourselves? I know we can, but explain this, how quantum works with this, our health, our longevity, and how we quote unquote even manifest or make things happen, or find joy, or live the best lives based on what we can do, working with the quantum aspects of life.
I love this question. And you're absolutely right. We, as a species, as individuals, always seem to want to limit ourselves, right? We say, oh, we're 70, oh, therefore we're whatever, or
Yeah.
we're, you know,
Old.
old, or we wear glasses, therefore we're whatever, blind, or that those kinds of things in the quantum perspective, in the universal cosmic perspective, really, we can think about it in many different ways. Those are purely constructs that we can avoid if we wish. Now, as far as age, let's talk about that. It is 100% true, for example, that we do age as human beings and we change as we grow. And at one point we're alive, and at one point we might not be. But that's true for stars too. That's true for universes. That's true for atoms and molecules. They are something, they change, and then they become something that it's not anymore. So if you understand that's true for everything, then you don't limit yourself with that knowledge. We human beings, we live about 100 years, give or take. Um, there are stars that live for 100 billion years, right? Give or take. And then there are mayflies and dragonflies and things like that that live for hours or even minutes, days, and then they change into something else. They are no longer what they are. If we recognize that all of that kind of time is relative and that our measurement of what is long or short in a time interval is completely based on what we choose to categorize it to be, what we compare ourselves to, then we can free ourselves from some of those uh, quantities, not quantum, but quantities that we restrict our lives to. Thinking on a quantum level means that we are able to think of different ways and different things beyond our regular everyday existences. And I think that is a very freeing, it's a very liberating knowledge and understanding. We know how things work on a quantum level, then we know a lot more than what we are told limits our existences.
And that's exactly what I want to get to, how people can have an impact by their self-talk and even their outward talk, in terms of, you
Right.
start bringing the bad stuff and saying everything's bad, you're gonna, you're gonna bring it. You're gonna bring it, more of it. But if you're positive and you don't say, "Oh, I'm at this, I'm old now," then you won't be. Just keep going. Go with how you feel, and I think that's the important aspect. So, and how people can work with quantum. Now, there's so much more with this book, and there's so many great topics and so many great answers. I want to call this part one. I hope we can do this again, Doctor.
It would
Just
be a pleasure.
amazing. We didn't get into nuclear. We didn't get to the atomic bomb. We didn't get into antimatter, and so much more, how MRIs and things like that. But I want to get to all of that. So let's do it again. But in the meantime, tell everybody quickly where they can find more about you and get your book.
Oh, thank you so much. You can pick up the book, of course, in anywhere that you get bookstores, online or in person or anything like that. On social media, I'm most easily found with the podcast link at the Luniverse. So THE and then LIU Niverse. Uh, THELIUNIVERSE on all kinds of channels, wherever you get your social media and podcasts.
Fantastic. Well, thank you so much for being on the show. Keep doing what you're doing, and thank you for making things accessible. These are important concepts and important knowledge that people need to know. And we'll have you back here on Guys Radio.
Thank you so much. Thank you so much for having me.
If you enjoy the guests and content I bring you each and every week, the Guys TV and Guys Radio, please support us by subscribing to our channels. Thank you.